ग्रुप थर्ड। ग्रुप थर्ड में 3 रेडिकल होते हैं, एल्यूमिनियम +3, आयरन +3, क्रोमियम +3। ठीक, और जो प्रेसिपिटेट इसमें बनेगा LOH3 वाइट, FeOH3 रेड ब्राउन, CrOH3 ग्रीन। Now the first test is in Al+3 solution. If we add NH4Cl followed by NH4OH, OH minus will combine with Al+3 to form white precipitate of LOH3. Similarly, if we add NaOH solution in Al+3 solution, OH minus will combine with Al+3 forming a white PPT of LOH3. And this white precipitate is soluble in excess of NaOH. Means it will dissolve because it is amphoteric hydroxide. Amphoteric hydroxide means it can react with both acid and base. React with both acid and base. So LOH3 will react with NaOH excess and dissolve, forming a aqueous solution of LOH4 minus ion. Or we can write is sodium meta-aluminate. Sodium meta-aluminate. Right. When LOH4 minus solution is formed, if we add ammonium ion in this solution, the ammonium ion will take OH minus ion from this complex, and again white PPT of LOH3 is formed. So L+3 gives white PPT with NaOH, which is soluble in excess of NaOH, and if in this solution we pass ammonium ion converts into ammonia, and again white PPT is formed. Next test is, if we add acetate ion in L+3 solution, white PPT is formed, LOH whole twice CH3CO minus. In L+3 solution, if we add hydrogen phosphate, it gives white precipitate of aluminium phosphate. Cobalt nitrate test is used in qualitative analysis when Al2O3 is white mass. To identify this Al2O3, if we add 1-2 drop of cobalt nitrate, and this whole solution is heated. So cobalt nitrate after dissociation gives cobalt oxide. Now what will happen? This cobalt oxide will combine with L2O3 forming a COAl2O4, which is blue colored mass. So this is cobalt nitrate test for aluminium. Next radical is Fe+2. In Fe+3 solution, if we add NH4Cl, ammonium chloride, followed by NH4OH, OH minus will combine with H3, forming a red-brown PPT of FeOH3. If this red-brown PPT is heated, it forms Fe2O3 compound oxide. Okay. This red-brown precipitate of FeOH3 is soluble in dilute HCl. It will combine with Cl minus ion, forming a aqueous solution of FeCl3. Now for confirmatory test, we can divide this solution into 2 parts. In the first part, we can add potassium ferrocyanide. Potassium ferrocyanide, this has ion into -4 charge. So Fe+3 and this ion will combine to form Fe4, FeCN6(3). This compound is called as Prussian blue and it is blue colored compound. So Fe+3 plus this ion having -4 charge form Prussian blue precipitate. This precipitate when dissolved in NaOH solution again gives red precipitate of FeOH3. Now the second part of FeCl3 solution. In this solution we are adding potassium thiocyanate. Potassium thiocyanate. So what will happen? This potassium thiocyanate will give SCN minus ion. This SCN minus will combine with Fe plus 3 obtained by this solution. So Fe plus 3 and HCN minus will form aqueous solution of FeCN HCnO3, which is blood red in color. In this solution, if we add F minus ion, it will bleach this solution, means it will remove the color blood red. So this solution forms a complex FeF6 whole minus 3 complex and bleach of the blood red color of FeHCN whole 3. If we are testing Fe plus 2 with potassium thiocyanate, there is no color obtained. So Fe plus 3 gives test with KSCN, while Fe plus 2 does not give test. This is the difference. If we add potassium ferricyanide, this is ferricyanide ion. Potassium ferricyanide has minus 3 charge. It combines with Fe plus 3, forming a brown color, which is FeCN whole 6. If we add Fe plus 3 into H2S solution, what will happen? That Fe plus 3 will be reduced into Fe plus 2, and it will oxidize H2S into milky white appearance of sulfur. Next reaction, in Fe plus 3 solution, if we add diammonium sulfide, it will convert it into FeS and sulfur is obtained. FeS is black in color. If in this precipitate we pass oxygen along with water, then FeOH3 red PPT is again obtained. So the next test is of Fe plus 2 ion. If we add FeCN whole 6 minus 3, this is ferricyanide ion. So the compound expected is plus 2 charge and minus 3 charge. After cross multiplying it, the compound must be formed as Fe whole 3, FeCN 6 whole twice. Charge is cross multiplied, twice this and thrice of this. The compound was named as Turnbull's blue. But after some years, it was found that actually this compound is not formed. Instead of this, what was later discovered, that Fe plus 2 when react with FeCN 6 minus 3, Fe plus 3 is oxidized into Fe plus 3, and this ion is reduced into FeCN 6 minus 4. And if we combine these two ions, then charge is cross multiplied, and the compound form is Fe4 FeCN 6 whole 3. And the compound is named as Prussian blue. So we can say that after the reaction of Fe plus 2 with ferricyanide, Turnbull's blue is not found. Instead of it, Prussian blue is formed. The next reaction, Fe plus 3 combined with thiocyanate ion, forming a blood red solution of FeHCN whole 3 aqueous. If we combine this solution with Hg plus 2, then Fe plus 3 ion is formed along with HgSCN whole twice is formed. Freshly prepared Fe plus 3 solution, when acidic solution is added, it gives a red-brown solution of this formula. Fe3OH whole twice, CS3CO whole 6 plus charge. In this red-brown solution, if we add water, dilution is done. If we add water and somehow it is heated, so what will be formed? Red-brown precipitate is formed. The formula is FeOH whole twice, CS3CO red precipitate. In Fe plus 3 solution, if we add hydrogen phosphate, it forms FePO4 yellow-white precipitate. Next ion is Cr plus 3 ion. Okay. NH4Cl is followed by NH4OH. OH minus will combine with Cr plus 3, forming a green precipitate of CrOH whole 3. This precipitate is soluble in ammonia and it forms a pink color complex. The formula is CrNH3 whole 6 plus 3. Now we are further confirming CrOH3 complex precipitate. If this precipitate is fused with potassium nitrate and sodium carbonate, The compound form is sodium chromate. This is sodium chromate. In this compound, water is added. So this is soluble in water, forming a aqueous solution of Na2CrO4, which is yellow colored. In this solution, we are taking two parts of this solution and lead acetate is added. Lead acetate gives Pb plus 2 ion. Pb plus 2 combines with CrO4 minus 2 ion, forming a yellow precipitate of PbCrO4. Now again, in this solution which is containing CrO4 minus 2 ion, if we add BaCl2 solution, BaCl2 gives Ba plus 2, which combines with CrO4 minus 2, forming a yellow precipitate of BaCrO4. So we can say that this green precipitate gives, after fused with potassium nitrate and sodium carbonate, gives a sodium chromate solution which is yellow colored. In this solution, if Pb plus 2 is added, yellow precipitate is formed. If BaCl2 is added, yellow precipitate is formed. Next reaction, if plus 3 solution NaOH is added, again green precipitate is formed. In green precipitate, if we add excess of NaOH, this precipitate is soluble in NaOH, forming a complex CrOH whole 4 minus. This is reacting with NaOH, means it is also amphoteric hydroxide. So Cr plus 3 with NaOH gives green precipitate which is soluble in excess of NaOH, forming this complex. In this complex, we are adding H2O2, hydrogen peroxide, in basic medium. Here hydrogen peroxide is acting as an oxidizing agent which can oxidize Cr plus 3 ion into Cr plus 6 form. So chromate ion is formed in aqueous solution. In chromate aqueous solution, if we add AgNO3, so Ag plus will combine with this ion, forming a brick red precipitate of Ag2CrO4. So Cr plus 3 plus NaOH, which gives a complex in excess of NaOH. In this excess of a complex, we are adding H2O2. Chromate solution is formed which gives brick red precipitate with silver nitrate solution. Next, in group third, if we are forming yellow solution of sodium chromate, if we add H2SO4 in this solution, H2SO4 gives H plus and which can displace Na plus ion, forming an acid which is named as chromic acid, and the formula is H2CrO4. In this acid, if we add H2O2, hydrogen peroxide, in presence of amyl alcohol, then blue compound CrO5 is formed. This blue compound, this is very important test for Cr plus 3. This blue compound, the color fades when H2SO4 is added, forming Cr2SO4 whole 3 along with oxygen gas. And CrO5 has butterfly structure like this, and chromium is in plus 6 state. This is the structure of CrO5. So next, cationic radical is group 4 radical. There are 4 radicals in this group: Zn plus 2, Mn plus 2, Ni plus 2 and Co plus 2. The group reagent is H2S gas. So we are passing H2S gas in third group filtrate, and this gas is passed in presence of NH4OH. This NH4OH was added during testing of third group radical. Already it is present in the test tube. So we are doing the sequential testing. Like in the for the first group, we put dilute HCl in the solution. If precipitate is not obtained, we are passing H2S gas in presence of HCl, second group. Then for the third group, we added NH4Cl along with NH4OH, so the third group was precipitated out in the form of hydroxides. Now the third group filtrate, the remaining of third group, in this solution we are testing for group 4th. So NH4OH was already present. Now H2S gas is again passed. But this H2S gas this time is passed in presence of NH4OH, which is providing basic medium. What is meant by basic medium? That it will dissociate to give OH minus ions. And this OH minus ion will react with H plus ion obtained from H2S gas. So what will happen? The concentration of H plus will decrease, and as soon as it decreases, reaction proceeds into forward direction. And because reaction is proceeding in forward direction, more number of S minus 2 ions are produced. Why we need more number of S minus 2 ions? Because for fourth group radicals, the Ksp of sulfide is high. And if Ksp is high, they need more S minus 2 ions. During the second group, H2S gas was passed in presence of HCl. In presence of HCl, H2S gas dissociation will be less in presence of common ion effect. And less number of S minus 2 ions were present during the second group. While in the fourth group, we need more number of S minus 2 ions. So we are passing H2S gas in presence of NH4OH solution. Now the chart is that third group filtrate, we are passing H2S gas, and these 4 precipitate will form of group 4. So group 4 precipitate of sulfide is ZnH is white, MnH is light pink, NiS and COS both are black. So after getting this precipitate, what we will do? We will dissolve this precipitate into dilute HCl. Now 2 cases will obtain. If the precipitate is insoluble, it might be either COS or NiS, both are black. And if precipitate dissolves in dilute HCl, solution is formed. That solution may contain ZnCl2 or MnCl2, both are aqueous solution. So these two will dissolve in dilute HCl, while these two are insoluble in dilute HCl. Now we are seeing the testing for COS or NiS. Both precipitate are black in color, COS and NiS. So the next step is that we will dissolve this precipitate in aqua regia. After dissolving, we will evaporate this solution to dry. Now what will happen? If blue residue is obtained, it might be COCl2. If yellow residue is obtained, it might be NiCl2. What we will do with blue residue? We will dissolve into water. The solution becomes pink colored. And the next conformity test, we will add ammonium hydroxide, acetic acid and KNO2. If yellow precipitate of K3CO NO2 whole 6 is formed, it is confirmed as CO plus 2. The next test for yellow residue NiCl2. When it is dissolved in water, it forms a green color solution. In this green color solution, we are adding NH4OH in excess amount along with DMG, dimethyl glyoxymethyl. So what will happen? This DMG will form a complex with nickel plus 2, and this complex, this precipitate is rosy red, and the formula is this. Means I can write that nickel DMG whole twice. This is the short representation of this complex. DMG is acting as a ligand. It is a bidentate ligand. So the coordination of nickel plus 2 is 4. So 2 bidentate ligand is present there, and rosy red precipitate is formed. So this is the popular test of nickel plus 2 along with DMG. Now remaining 2 precipitate were ZnS and MnS. It was white and it was light pink. When we dissolve these 2 precipitate in dilute HCl, they readily dissolve to form Zn plus 2 or Mn plus 2 solution. The next step, in this solution we will add bromine water in presence of NH4OH. This bromine water is oxidizing agent. So what will happen? It will oxidize Mn plus 2 into MnO2. and black precipitate is formed from Mn plus 2. We are adding bromine water along with NaOH. So it converts into plus 4 state, oxidized into MnO2, and the black precipitate is formed. What we'll do? This black precipitate is dissolved in concentrated HNO3 and PbO2 is added. PbO2 is a strong oxidizing agent. PbO2 is a strong oxidizing agent. So what will do? It will further oxidize Mn from plus 4 state to Mn plus 7 state, and the purple color solution is formed of HMnO4. This is called as permanganic acid. ठीक? So black precipitate is dissolved in constant HNO3, PbO2 is added, further oxidized into HMnO4, purple solution is formed. This was the testing for Mn plus 2. Now Zn plus 2 is not oxidized further because it is its highest oxidation state. So what will do Zn plus 2? It will dissolve in NaOH. Zn plus 2 dissolve in NaOH, forming a solution of NaZnO2, Na2ZnO2, or we can write it as simply ZnOH whole 4 minus 2 complex. Either हम ये लिख दें या ये लिख दें. So Zn plus 2 dissolve in NaOH, forming a complex or solution of Na2ZnO2. If we pass Zn plus 2 in this solution, again this gas will precipitate ZnS, which is white in color. So this is the chart for group 4 radical. In group 4 radical, we are individually testing Mn plus 2. So in Mn plus 2, we are passing H2S gas and light pink precipitate of MnS is formed. This light pink precipitate is dissolved in HCl to form MnCl2 solution aqueous. We are adding NaOH in this solution, so Cl minus will be replaced by OH minus ion and MnOH2 is formed. If we add Br2 along with NaOH in MnOH2, so what will happen? That when bromine with NaOH, it forms NaBr plus NaOBr, and this NaOBr gives oxygen, which is oxidizing agent. So in this bromine in NaOH is acting as a oxidizing agent. So Mn from plus 2 state is oxidized into plus 4 state, and the precipitate MnO2 is black in color. So this MnS is dissolved in HCl, then NaOH is added, then bromine water is added. So it is oxidized into MnO2 black. Now the next MnO2 black precipitate is dissolved in concentrated HNO3 and it converts into Mn plus 2 solution. Now after dissolving, when we add PbO2 as a strong oxidizing agent, it will oxidize Mn plus 2 into MnO4 minus ion, which is purple in color. So PbO2 will oxidize Mn plus 2 into MnO4 minus. Now the next test is MnCl2. When NH4OH is added, OH minus will replace Cl2 and white precipitate of MnOH2 is formed. Next, MnCl2, when dissolved in NaOH, it forms MnOH2 white precipitate, which dissolves in excess NaOH, forming a solution. Mn plus 2 plus ammonia plus hydrogen phosphate gives pink color precipitate of MnNH4PO4.